So we've talked about different types of numbers. We've talked in earlier conversations about integers and whole numbers and negative and positive, even, decimals, fractions. But we haven't talked about a really special type of number that's foundational to so much of what we do in algebra. It underlies a lot of the thinking. And they're called prime numbers, and you may be familiar with them already. So what I want you to do is go get some coins. I want you to have a spot to sort of maneuver these around a little bit. Go get 8 coins and pause the video and come back. And so what I want you to do is take those 8 coins and arrange them into a rectangle. And once you do that, see if you can make other rectangles. So the goal is to make as many different rectangles as you possibly can from 8 coins. And so as you do this, you might come up with this rectangle, right? Which, if you outline it, looks like this. So it's, a 2 by 4. Or maybe you did the same 2 by 4, but you did it like this. So, you might look at that. Whoops, I wrote 4. You might look at that as a 4 by 2, right? So it's the same rectangle, just oriented a different way. Or maybe some of you did this. You just put them all, in one row. 1, 2, 3, 4, 5, 6, 7, 8. Or maybe like this: 2, 3, 4, 5, 6, 7, 8. Right? So you can sort of stack them. And in both of these, you have a 1 by 8 or an 8 by 1. Okay. So then what I want you to do is take one of those coins away and do the same thing with just 7 coins. Try to make some rectangles. Pause the video, come back. What you're going to find is that if you want to make a rectangle out of 7 coins, the only way to do it is 1, 2, 3, 4, 5, 6, 7. Or if you stack them vertically, 1, 2, 3, 4, 5, 6, 7. You can't do anything else. You don't have any other options. It's either 1 by 7 or 7 by 1. Again, it's the same rectangle, 7 by 1. It's the same rectangle, it's just rotated. This is what prime numbers are all about. 7 is a prime number. There are no more options. There's only one option. There's only one option for arranging 7 things, right, into a rectangle. 7 is a prime. 8 has options, right? We have multiple options. We have really 2 options. More than one option. This is called a composite number. Composite. So the idea of prime numbers really comes down to, here's this word again, factors. How many factors does the number have? Because if you recall, factors are the things that can multiply together to make the number. 8 could be equal to 1 times 8 or 2 times 4, right? That's what those rectangles represent. 7 could only be represented by 1 times 7. Numbers like this are called prime. Prime numbers only have 2 distinct factors. That's the definition. Have 2 distinct factors. Factors meaning different. Composite numbers have more than 2 distinct factors. 8 had factors of 1, 2, 4, and 8. 7 had factors of 1 and 7. And that was it. I really like showing this idea on a number line so you can kind of see what happens. 2 is the first prime number. Because why is 1 not a prime number? See if you can come up with that answer and then come back to that. 1 is not a prime number because it only has one factor. 1. 1 times 1. Remember, a prime number has to have two distinct factors, two different factors. So 2 is the first prime number. 1 is not composite or prime. It's neither. So for prime numbers, we start at 2. And then if you look at multiples of 2, right? Let's jump count by 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We're getting some good number sense by visualizing this. All of those numbers are composite numbers because by being a multiple of 2, they automatically have 2 as a factor. So they can't be prime. These all must be composite. So I'm going to cross them off the list. We're going to identify simply the prime numbers right now. Gone, 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 right? Those are all, the ones I just crossed off are all multiples of 2, which means they are composite. Well, let's look at 3. Let's look at 3. Actually, let's just do it on the same chart here. Let's look at 3. Let's do the same thing. I'm going to use blue and jump count by 3. So 6, 9, 12, 15, 18. What you'll notice is that some of those numbers were already crossed out because they were multiples of 2. Like 6 is a multiple of 2 and a multiple of 3. So it's definitely composite. 9 was not crossed off before. It was an odd number, so it's not a multiple of 2, but it is a multiple of 3. So we're going to cross that one out. We're also going to cross off 15. So we're narrowing our list down. Let's keep going. So let's look at 5. If I look at 5, that's the next prime number. 5 times 1. That's it. If we jump count by 5s, we go 10, 15, 20, which were all already crossed off. What about 7? 7's the next prime number. Let's jump count by 7s. Well, we can only go to 14, which was already crossed off. And if we keep going, we actually find out that the rest of these, 11, 13, 17, and 19, are all prime numbers. They're the weird numbers that never show up on a multiplication chart. You don't run into them as much when you're doing mathematical operations, especially with multiplication and division. And so that's the idea of prime numbers. And so what we're going to do is we're just going to check a couple numbers. So I'm going to give you a number, and your job is to determine, is it prime or not? We're going to just play a little game. Is it prime? Is it prime? So I'm going to give you a number. You pause the video and see if you can figure it out. Is it prime? The first one is 91. So pause, see if you can figure this out. Then come back. Now, I haven't told you how to figure that out yet, but the way you do it is if you think about what we were doing up here with the number line. What we're trying to do is determine if 91 has any other factors other than 1 times 91, right? Does it have any other factors other than 1 and 91? And factors, right? Factors would be things that 91 is divisible by. So you can check to see if 91 is divisible by other numbers, specifically the prime numbers. So we're just going to check to see if 91 is divisible by any of these other prime numbers. We don't have to do the non-prime numbers because, think about this. Now, this is one of these times where you want to pause after I say it and then just think about it. Something you can't do in class. You can do on a video. If 91 isn't, well, let's do it. We try it. 91, can we divide 91 by 2? No. If we do 91 divided by 2, we get 45.5. 91 divided by 2 is a decimal. And what we're looking for are whole numbers. It's 45.5. And that is a decimal. So 2 is not a factor of 91, which means no other multiples of 2 are going to be going to 91. right? If 91 is not divisible by 2, it's not going to be divisible by any multiple of 2. So let's try 3. 91 divided by 3. 91 divided by 3. It's going to give us, whoops, 91 divided by 3. I can't type. 91 divided by 3. It's not showing. It's not doing it properly. 91 divided by 3 equals. For some reason, this calculator is not showing what I want it to show. There we go. I did not have the full thing displayed. It's 30.3, right? So it's 30.3, and that 3 is repeating, okay? So we just keep going through the prime numbers. 91 divided by 5, and that comes out to be another decimal, 18.2. And at some point, you're like, how far do we have to go? Well, let's see, 91 divided by 7. 91 divided by 7. Oh, look what happened. 91 divided by 7 is 13. 91 is a multiple of 7 and 13. 7 times 13 equals 91. So what does that mean? It means 91 is not prime. 91 is a composite number. 91 is a composite number. So that's how you check to see if a number is prime or not. You just divide it by other prime numbers. So we're going to do one more. We're going to try 71. And I'm going to tell you right now that 70, well, you try it and then come back. I'm going to tell you right now, after you've come back, that 71 is a prime number. I'm just going to tell you that. I'm telling you that because if you think about this process, eventually you have to know when to stop. So we're going to do the same thing. 71 divided by 2, divided by 3, divided by 5. We're just going to keep dividing it by prime numbers. All right? So 71 divided by 2, 35.5. So that didn't work. 71 divided by 3, 23.6 repeating. 23.6 repeating. 71 divided by 5, 14.2. Just keep going and going. 71 divided by 7, 10.14. Right? We know it's a decimal, right? It would round to something else. Let's keep going. 71. What's the next prime number? Divided by 11. Is that the next prime number? 71 divided by 11. 6.45, and then 4.5 repeats. Right? Okay. So this is actually the spot you can stop. And you're thinking, well, how do I know that? How do I know when to stop when I'm doing this test? And here's how. Actually, pause and see if you can figure it out. Here's how. Look at what you're dividing by. Small number, 2. Your answer is a pretty big number, 35.5. As these numbers get progressively bigger, 2, 3, 5, 7, 11, what's happening to these numbers? They're getting progressively smaller, right? These two numbers are starting to actually get closer to each other. 2, 35, 3, 23, 5, 14. They're getting really close. 7, 10. Once you get to this spot where they switch, right? Where your answer gets your answer gets smaller than what you were dividing by, that's actually the time you can stop, because we've already checked everything that's below 6. As we keep checking bigger and bigger numbers, this number is going to get smaller and smaller. And we've already checked every prime number below 6. We checked 5, we checked 3, we checked 2. So we already know they don't work. So now is the time we can stop. And we now know that this is prime. So now you know how to check for prime numbers.